Now let us consider an example where we want to perform a 45-degree rotation of a triangle ABC with respect to some arbitrary point, pivot point, that is -1, -1. Now, after getting the composite transformation operator P as specified in my previous lecture, then we can apply that operator, that is rotation operator with respect to P through an angle 45. After getting this operator, we can apply this operator on A, we will get A dashed. We can apply the same operator RP 45 on B, we will get B dashed, and the same operator is operated on C, we will get C dashed. Now, instead of applying separately, we can do one thing, we can represent the multiple point on the object, in this case the 3-point ABC, as another matrix, object matrix, where A is specified by inhomogeneous coordinate system as 0, 0, 1. Similarly, B is specified as 2, 2, 1, 1 is scale factor, and C is specified as 5, 2, 1. So, this is the object matrix, and this is operated on this every object point. We are operating rotation operator with respect to P through an angle 45. This is operated, and we will get the corresponding transform point A dashed, B dashed, C dashed. We will get that matrix. So, our first task is to obtain this composite matrix operator, and then we will just multiply this on this object point, we will get the corresponding transform points, and then we can redraw the object in the new positions, we can get the transform object. Now, let us see how we can obtain these composite operators. Now, as per step 1, we will first translate P, translate P -1, -1 to origin, that is 0, 0. Let us call this operator as T minus V, where what is T minus V now? So, T minus V is nothing but 10 Tx, 10 Tx. So, here what is Tx? Tx is -1. So, what is minus Tx? Minus of -1, that is 1. So, in this case this is 1. So, 0, 1, Ty in this case, as it is minus B. So, this is minus Ty. So, minus Ty means minus of -1, that is 1, and 0, 0, 1. So, this is T minus V, because in this case what is V? V is -1 into I cap plus -1 into j cap. So, this is nothing but minus I minus j. So, this is your V. So, whenever you are saying minus V, this is 1, minus Tx minus Ty is this. So, this is Tv. Now, what is step 2? Step 2, after step 1, P is now coincident with the origin, that is 0, 0. So, now you will perform rotation through a 45 degree. So, that is perform rotation with respect to origin through an angle 45 degree. So, this operator is R 0, 45. So, this is nothing but, as we have already derived that is cos theta minus sin theta, that is cos 45 minus sin 45, 0, sin theta, that is sin 45, cos 45 0 and 0 0 1. So, this is okay. We can put the value or we can put the value at the end. Basically, effect is same. And step 3, we have to give the inverse operation of step 1. So, this is perform back translation from origin 0 0 to okay, p minus 1 minus 1. So, this is inverse of step 1. We are calling this operator as t okay, v, and definitely t v is 1 0 minus 1 0 1 minus 1 0 0 1. So, to obtain the composite operator okay, that is rotation with respect to p through an angle 45, we are first multiplying okay, 1 0 minus 1 0 1 minus 1 0 0 1. So, this is first okay. First one is this one, this is the left hand side okay. So, this is 1. First we are applying t minus b. So, let us write that step first. So, how this will be obtained? So, first we are applying step 1. First we are applying step 1, that is t minus v. Onto that we are applying rotation with respect to origin through an angle 45, and then we are applying t v, and this is operated on the object point. So, these are the 3 operators operated okay, one after another. Now, put the values. Now, what is t v? Okay. T v means this one. T v is 1 0 minus 1 0 1 minus 1 and 0 0 1. So, this is t v. Now, what is r 0 theta? R 0 theta, R 0 45 is cos 45, that is 1 by root 2 okay. Minus sin 45 means minus 1 by root 2, and this is 0. This is 1 by root 2 0 0 0 1, and then it is operated on okay. On this you are applying t minus b, which is okay. What is t minus b? Is the first one, step 1, that is 1 0 1 0 1 1 0 0 1. Now, if you multiply these 3 in any order, either you can multiply these 2 first with that result with this, or you can multiply these 2 with that result this, because you know that matrix multiplication is associative. So, if we multiply these 2, we will get this is this into this. So, only 1 by root 2 is there, then this into this minus 1 by root 2, then this into this is minus 1. Then we are multiplying this into this. So, only this part will be there, 1 by root 2, then this into this, then 1 by root 2, then this into this is minus 1, then you are multiplying this is 0, then this is multiply this is 0, and this into this, that is 1, and it is 1 0 1 0 1 1 0 0 1. With that we are now we are multiplying these 2. So, this result value will be this into this. So, this is 1 by root 2, then this into this is minus 1 by root 2 okay. Then this into this okay. So, this is 1 by root 2, this into this plus this into this, that is minus 1 by root 2, this into this plus this into this, that is minus 1, then this into okay, this is okay. Now, this into this, so this is okay 1 by root 2, this into this, then this into this is 1 by root 2, then this into this. So, this is okay, 1 by root 2 plus 1 by root 2 okay, minus 1, 1 by root 2 plus 1 by root 2 into minus 1. After that, this into this. So, this is 0, this into this, that is 0, then this into this, that is 0, then this is 1. So, this is the composite operator. So, after simplification, this becomes 1 by root 2, 1 by root 2, and this is cancelled out, this is minus 1, and this is 1 by root 2, 1 by root 2, and this is okay, root 2, 2 by root 2, 2 by root 2, this is 2 by root 2 minus 1, that is root 2 minus 1, and this value is 0 0 1. So, this is our composite operator. Now, this operator will be operated on the object point, that is this point, we will get the corresponding transform points. Now, when we will apply this, let us see that A dashed, B dashed, C dashed, this okay, is obtained by multiplying this operator okay, 1 by root 2, 1 by root 2 minus 1, this is 1 by root 2, 1 by root 2, root 2 minus 1, and this is 0 0 1. So, this is operated on this object point, that is ABC, that is 0 2 5, and then 0 2 2, and then 1 1 1 1 1 1. So, if you multiply these two, okay, if we multiply these two, we will get the corresponding transform, this into this, right. So, this will be okay, minus 1, this into 0, this into 0, this into this. After that, this into this, that is root 2, root 2 by 2, this is okay, this into this plus this into this, that is plus root 2 okay, plus minus 1, this is the second value. And for third one, this into this, that is 5 by root 2 okay, plus 2 by root 2 okay, minus 1. And for the second row, this into this, that is okay, root 2, this into 0, this into 0, plus this into this, that is root 2 minus 1, and this into this, that is 2 by root 2 plus 2 by root 2 okay, plus root 2 minus 1. So, this is for the second one, and for the third one is this into this, that is 5 by root 2 plus 2 by root 2 plus root 2 minus 1, and this into this, that is 0, this into this, that is 1, 0 into 0 plus 0 into 0 plus 1 into 1, that is 1. I am writing the final result 1 1. So, after simplification, this becomes minus 1 root 2 minus 1 1. Then this is 2 root 2 minus 1 okay. So, this is root 2 plus 2 root 2 plus root, that is 3 root 2 minus 1, 3 root 2 minus 1, and this is 1, and this is 5 by root 2, 7 by root, that is 7 by root 2, 7 by root 2 minus 1, this is 7 by root 2 plus root 2 okay, 7 by root 2 plus root 2, that is 7 by root 2 plus root 2 minus 1, and this is 1. So, we can write this as 9 by root 2. We can simply write this is 9 by root 2, 9 by root 2 minus 1, 9 by root 2 minus 1, and this is the final result. So, what is A dash? In all the cases the scale factor is 1. So, your A dash is minus 1 root 2 minus 1. What is B dash? B dash is 2 root 2 minus 1 and 3 root 2 minus 1, and C dash is 7 by root 2, okay, minus 1 and 9 by root 2 minus 1. So, this is your C dash. So, this is the final result. Okay, thank you.